Download this code from codegive.com, link in the description below. Sure. Anti-debugging techniques are methods used by software developers to prevent their programs from being analyzed or manipulated by debuggers. This can be important for protecting software from reverse engineering, piracy, and other forms of tampering. Basic anti-debugger techniques. Here are some basic techniques you can use to detect if a debugger is present and potentially alter the program's behavior if one is detected. 1. Check for debugger presence *. Use system calls to check if the process is being debugged. 2. Timing checks *. Measure the time it takes to execute certain functions. Debuggers can slow down execution, so significant delays can indicate that a debugger is present. 3. Exception handling *. Certain exceptions can be triggered when a debugger is present. You can check for these exceptions. 4. Using operating system APIs *. Use OS-specific APIs to check for debugger presence. For example, on Windows, you can use isDebugger present. Example code. Here's a simple example of how to implement a basic anti-debugging technique in C++ on Windows using the isDebugger present function. CPP. Include iostream. Include windows.h. Void anti-debug. / check if a debugger is present. If, is debugger present? std_cout debugger detected. Exiting, std and l. Exit process, 1, / exit the program. Else. std_cout no debugger detected. Continuing, std and l. Int main. Anti-debug. / the main logic of your program. std_cout running main application logic, std and l. / simulate some work. 4, int I equals 0, I5, ++ I. std_cout working, std and l. Sleep, 1000, / sleep for 1 second. Return 0. Explanation of the code. 1. Include necessary headers *. We include iostream for input/output operations and windows.h for Windows-specific functions. 2. Function anti-debug *. We define a function that checks if a debugger is attached to the process using the isDebugger present function. If a debugger is detected, it prints a message and exits the program using exit process, 1. If no debugger is detected, it allows the program to continue. 3. Main function *. We call the anti-debug function at the beginning of the main function. We then simulate some work with a loop that prints working and sleeps for a second. Notes on effectiveness. Limitations *. While basic techniques can deter casual analysis, advanced reverse engineers may still bypass these methods. Legal and ethical considerations *. Implementing anti-debugging techniques should be done responsibly and ethically. It's important to respect users' rights and not infringe on legitimate use cases. Testing *. Always test your anti-debugging measures in a controlled environment to ensure they do not interfere with legitimate debugging needed for development and troubleshooting. Conclusion. This tutorial introduced you to basic anti-debugging techniques with a simple C++ example. For a more robust implementation, consider combining multiple techniques and making your checks more complex to deter potential reverse engineers effectively.